Okay, Garnet Valley Middle School 8th grade science students, here's another video for us today on how machines do work. And at this point, we should have read what work is and how we calculate work. And that is by multiplying force times distance. And when we measure the force in newtons and the distance in meters, we end up with the new unit for work, which is the joule, which is capitalized with a J. Newtons are capital N, but meters are a lowercase m. So that's how we abbreviate them. And of course, we know that work is when a force moves something from one place to another. So now that we know what work is a machine exactly? A machine is an instrument that makes work easier. Sometimes we say that they help us do something. Machines can either increase or decrease the force we put into them, or they can just change the direction of that force, whatever makes it easier for us. As far as how machines actually help us do work, we have to look at a couple of things here. So in this picture, I have a fictional machine there. It's just a square with some gears in it. And we have work input going into the machine, and then we have work output coming out of the machine. And what that means is that you're going to do some amount of work on the machine. So let's say, for example, this machine was a hammer. We'll just make it something really simple. And you want to pull a nail out with a claw hammer. And so you grab the handle and you pull back on the handle. That's your input work. The claw part of the hammer, which is hooked onto the nail, pulls the nail out. That's the output work. So the hammer is the machine. So when you look at the input work and the output work, basically you can get one of three outcomes. Either the force and distance will stay the same, which might be a machine that just changes the direction for something like a single pulley, or the force can get decreased and the distance gets increased. Or the opposite can happen. The force can get increased and the distance can get decreased. So what do these things look like in example? To help explain or give an example of machines that increase force and decrease distance, or increase distance and decrease force, I got two machines that look very similar, but they're used very differently. This one you may recognize as a nutcracker, and this one as a set of cooking tongs for turning things over on the grill, like giant portobello mushroom caps that have been marinated, which is awesome. By the way, so this is a machine that is multiplying your distance, because if you look at it, at the end of the tongs there, that's about 13 centimeters that it has to close. But if you look at where my fingers are on there, if you hear that noise in the background, that's my daughter playing Fortnite. It's nice that she has no work to do and I do. If you look at where the handle goes though, where your fingers are, I'm only closing that about four centimeters, four and a half. So this thing is increasing the distance that my fingers are moving, so it must be decreasing the force. So let's just see if I can crush something. Here's a little piece of wood I got here. I'm gonna put that in the tongs. I'm gonna try and crush it. See, I'm actually bending it now. It's not crushing, it's not doing really anything to it. So let's look at the machine that's gonna increase force. So this one, you grab on the outside and squeeze that together. So on the outside, this one is gonna move about 6 centimeters, but at the inside, it's only gonna move about 2, once you get it in there. So let's just have a look what happens when I put the piece of wood in there, in the nutcracker, and then I'll just do it with, like this, ready? You can hear it crushing in there as we go. And you can see we marked it up pretty good. So this machine decreases the distance because your fingers move a greater distance than the inner part does. So if this one decreases the distance, that's going to increase the force. And this one increases the distance, so it decreases the force. But they're both useful in their own ways.